Okay, number 3 is going to be very similar to the one before, and don't be intimidated by how big the numbers are. It's really not too bad. So in the year 2000, there were 8.7 deaths per 1,000 residents. If there are 281,421,906 residents in the U.S. at that year, how many people died that year? Kind of a morbid question, but we'll figure it out. So we'll start by first looking at the question. So we want to know, based on residents, how many people died. So if we look at the first part, they say deaths per resident, so we'll write it in that order. It really doesn't matter as long as you're consistent throughout the problem. So deaths per residents. So the first thing they give us was 8.7 and then 1,000. So 8.7 deaths per 1,000 residents. Then we want to know if there were that many residents. So this number will go on the bottom to stay with residents. So 281,421,906 residents. We want to know how many deaths there would be. Well, you're in luck. I did the math, so you don't need to write it all out unless you want to check my math. So then we cross multiply. So we get 1,000x equals an even larger number. So it's 2,348,370,582.2. Perfect. Now you're going to divide both sides by 1,000, which essentially just means you're moving over the decimal. Got cut off a little bit. So then you have x equals, and then now it says about how many deaths. So you want to round to the nearest person because you can't really have a fraction of a person die, which would be 2,448,370, and then we'll round up to 1 deaths, which sounds like a lot, but out of 281 million people, just having 2 million die is not a ton. So that is your answer. All right, now number 4. This one should be pretty similar. We're going to use smaller numbers, so I think this one you might be able to follow if that one was a little too much for you. So in a shipment of 400 parts, we know 14 are found to be defective. We want to know how many defective parts should be expected in a shipment of 1,000. So we're asking about defective parts out of a whole shipment. It might get old to kind of write this that much, but it really helps you keep your numbers in line and know where each number is supposed to go and on which row. So we know defective over the total shipment. So we know 14 out of 400 are defective. Then we want to know how many should we expect to be defective out of 1,000. So just like before, we're going to cross multiply and get 400x equals 14,000. Divide both sides by 400. And you will get x then equals 35 defective parts. All right, number 5. Joseph can drive 125 miles in 2.5 hours. At the same rate, how far will he be able to drive in 6 hours? So we're talking about miles per hour, something that we should all be pretty familiar with. So how far is referring to the miles right there in 6 hours. So our question is asking about miles per hour. So that's how we're going to write our proportion, is doing miles per hour. So let's use the information that we're given. 125 miles in 2.5 hours. Now, to write 2.5 hours as a decimal, that would be the easiest way to do it, so you can put it in your calculator. 1/2 is just 0.5, so this would be 2.5. And then we're given that last piece is 6, and it's hours, so it's going to go on the bottom. So 125 miles in 2.5 hours. How many miles can you go in 6 hours? So you're going to cross multiply. 2.5x equals 750. Then divide both sides by 2.5 on each side of the equation. And then you get x is equal to 300 miles. So that's how many miles he could go in 6 hours. Now, I'm going to have you do number 6 on your own. I want you to try that one. And then I'll do a few more at the bottom. But for right now, I do want you to do 6 on your own.